Hi everybody again. Today I'm going to continue our topic on elimination method. In the first video, we spoke about the Gaussian elimination, which we base on elementary row operations. So we learned the essence, why we use this, and how we get these operations, these three operations. And today in this video, we are going to talk about elimination process. So for this purpose, we have written here a system, a linear system. You can see here a linear system of three variables. So it's 3 by 3 system, but you can apply this method for any other sizes, for 2 by 3, for 4 by 10, and any size. So it helps. So this method is considered one of the best methods. Actually, it is the best method which we use for solution of linear systems. So you know from the previous video that we are going to talk about the augmented matrix. So augmented matrix is the system in which expressed in coefficients. So let's write the coefficients here for each element. So 1, 2, -1, 3, 2, -1, -1, 2, 1, 1, 1, and 4. So what we have here, actually, the first column represents the coefficients of x. The second column seemingly are the coefficients of y. And the third column are the coefficients of z. And we have the limiting coefficients or constant terms from right side. So our purpose is to bring this matrix in the form that we call echelon form. So how are echelon forms formed usually? Let's see, for this system, it's the matrix. You can see it's 3 by 4 matrix. We can write such an echelon form which are preferable for solution of this system. So preferably we are going to get such a system. But in the end, we will see why we have here ones for which purpose. These stars represent any numbers that we can get here in the process. So it's important to get here ones, but we will explain why. After we get the solution, we are going to explain why. So let's start the solution process. So first, let's mention our three operations. First, we can interchange any rows. In our case, we don't need to interchange because the first row starts with 1. So it's already okay for us. Secondly, we need to be able to multiply any row by any number. So we can multiply any row here by any number. And thirdly, we can add this multiple to the any other row. So these are rights that we have for this matrix. So let's use them. For if you remember, we mentioned that under 1 we have got 2 zeros in echelon form. So first of all, it's our first purpose is to get 0 here. So we multiply the first row by -2 and add here. So -2 first row, row 1, we add to row 2. So what we get here, let's calculate. So first row we don't touch, 1, 2, -1, 3. So if you multiply by -2 the first row and add here, we're going to get 0, obviously. -2 plus -1, 2 times -2 is -4, plus -1 is -5 here. So -1 times by -2 is 2, plus -1 is 1 here. So -2 times 3 is -6, plus 2 is -4. Again, not using too much efforts, we can get 0 also here. So what we do, minus first row. So first row we multiply by -1 and plus row 3. So we can do it here at the same time. So multiply by -1 and add here, we get 0. So -2 plus 1, we have -1. Again, minus 1 times minus 1 is 1, plus 1 is 2. Yeah, so minus 3, because we multiplied this row by minus 1, minus 3 plus 4 is 1. So what we have here, actually, we have here the two below rows with 0. What I suggest here, we can, in order for simplicity, we can interchange row 2 and row 3. Let's interchange their places. So row 3, we change to row 2, interchange them. So what we get, we don't touch the first row. It's already okay for us. So it becomes 0, minus 1, 2, 1, 0, minus 5, 1, negative 4. So we don't change here anything. We have got such a right from elementary row operations, 3 elementary row operations. So what I do here, I can directly multiply by negative 1 the second row. So we get the second row, we multiply by negative 1. The way that I do this in detail, I want you to understand how we can use in different situations the operations, these operations, minus 2, minus 1, 0, minus 5, 1, and minus 4. So obviously we need to get 0 here. How we can do it? So we can multiply the second row by 5 and add to the third row. So 5 times second row plus third row. Let's see what we get here. Again, 1, 2, negative 1, 3, 0, 1, negative 2, negative 1. So 0, 0. So we multiplied by minus 5, I would like to remind you. So minus 5 plus, so 5 plus minus 5 is 0. 5 times minus 2, minus 10 plus 1 is minus 9. So 5 times minus 1 is minus 5 plus minus 4 against minus 9. So by dividing the last row by negative 9, row 3 divided by negative 9, so we get such a final case. Yeah, 0, 0, 1, 1. So what we get here, I would like to remind you that the first column are the coefficients again of x. We agree that the second column are the coefficients of y. The third are the coefficients for z. So these are the limiting or constant terms. So if now let's start from the last one. You see 1 times z is equal 1. Because 2 other x and y's are becoming here zeros because their coefficients are 0. They make it 0. So we don't need to write them. So 1 times z is equals to 1. From here we get z equals to 1, z equals to 1. In the next one, we can write the z1 to this row. So what we get, let's see. So again, 1 time 0 times x, 1 time y, minus 2 times z equals to negative 1. So if z is 1, then y minus 2 equals to negative 1. From here, we get that y equals to 1. So we have two variables here. The values for two variables, z equals to 1, y equals to 1. So we are going to use, of course, these two in the first row. So what we are going to get in the first row? So 1 times x plus 2 times y minus 1 times z is equal to 3. So we can place all the numbers here. Y is 1, z is 1. So x plus 2 minus 1 equals to z. Well, obviously we get x equals to 2. So we have such solution, x equals to 2, y equals to 1 and z equals to 1. You can check it. So it satisfies this. So what is essential here is the essential part coming back to ones here. You can see 1 makes it easier. So you can get here any number, 5, 6, 12, minus 1 out of 3. But working with 1 is easier. That makes it, that's the only thing that makes it easier here for in echelon forms. And in the previous one, you can see for x also we can say the same. For y also we can say the same. And for x in the uppercase also we can say the same. So we have solved today using the elimination methods. But which cases we can have? Let's suppose that we came up to a different situation. Suppose that we have solved our system and we came to such a final case. For example, 1, 2, 1, 0, 0, 1, 0, 3, for example. We get 0, 0, 0, 0. So the third row is absolutely 0. So in this case, what does it mean? It means that here we have got the free variables. So we can use the second and the first row to define these free variables. So in our case, we have here z 0 times z equals to z 0, which makes it obvious that z can be here the free variable, because in the second row you can see we have the coefficient of y, so it's actually 1 times y plus, so 1 times y plus 0 times z equals to 3. So 1 times y, from here we get y equals to 3, so which makes y dependent variable, so it's not free, but z is a free variable in our case, and it means that the system will have infinitely many solutions. So again, the system might have only one solution. It might have infinitely many solutions. We are talking about the linear systems, of course. And also there can be no solution case. So let's see an example of no solution case. Let's suppose we have such a augmented matrix in the end. So this case shows that we have here 0 times z equals to 5. It means that this system will not have any solutions, because the last row has got all coefficients 0, but the constant coefficient is non-zero. So this is the case when the system has no solution. And if you remember this case, we called it such a system, we called inconsistent system. So I hope it was useful to you. For more info, you can address to the books, you can ask me. So I wish you good luck in the exam. Do not forget to follow our videos, because there are going to be a lot of more interesting facts that are going to be used in the exam. So see you, bye, good luck to you, take care.